And if I'm not wrong, you folks have, Azul Platform Prime, which is a high performance Java platform. Can you talk about what are some of the critical capabilities that are at the heart of a high performance Java platform?
Right, exactly. So Azul's Platform Prime is an example of a high-performance Java platform, and there's a bunch of different things that kind of go into what we define as a high-performance Java platform, and the three most basic things are, first of all, improvement in terms of execution, code speed, right, being able to run the application faster. The second is being able to run the application more consistently. And the third is being able to address problems associated with Java applications in terms of how long it takes an application to start up and get fully optimized, which is called the warm-up problem. So a bit more detail on each of those. So code speed is fairly obvious, right? As an application is run, the JVM is responsible for dynamically compiling that application into the underlying machine where it's being run. And so the better the compiler, the faster the code runs. And so a high performance Java platform allows that the creation of more efficient code, higher performance code, and ultimately allows for higher throughput, lower latency, in essence, just faster code, improves the application. Secondly, in terms of the consistency of operation, there's a process in Java called garbage collection. And the process in general is responsible for allocating and freeing up memory as an application is run. And one of the reasons that Java as a platform is a very secure language relative to other things like, say, C and C++ and other language, the more legacy type languages, is because of the fact that the memory is managed by the Java virtual machine. It's not the responsibility of the application. Many of the kind of famous security vulnerabilities that you've heard of relate to poor memory management by the application, holes in algorithms in terms of allowing attackers to come in and attack the memory of the application. So all of that actually is much more robust in Java, but it does come at the expense of this process called garbage collection. And garbage collection basically is a process that happens during an application as it's run to basically free up memory. In a regular Java virtual machine, the freeing up and the coalescing of memory actually requires the application to stop. So you get these pauses while the application is being run. So it's a very important process and a necessary one, but also one that can impact performance. A high performance Java platform like Azul's Platform Prime inherently fixes that. And so it has very, very consistent operation and eliminates those long pauses associated with the garbage collection process. And then finally, when a Java application is run, I mentioned before that one of the challenges the Java application has is that it does take some time for the application to actually start up and eventually get to the fully optimized state. And this is sort of the downside of the fact that there is a compilation process that happens when an application is started, right? So like I mentioned, the JVM is responsible for compiling that application into the underlying instruction set. The downside of that is it takes some time. Compilation is a complex process. The more time you spend, in order to be able to generate high performance code, it does take some time to do that. And so that's what's called the startup and the warm-up time associated with the Java application. And so Azul Platform Prime has specific technologies, we call it ReadyNow, that addresses and significantly reduces startup and warm-up time commonly associated with regular JVMs.